What we're going to do is we're going to take a look at section 5.8, where we have equations with fractional coefficients. And we're going to remember, as we did in the past, to identify the LCD. And then what we can do is just simply multiply the equation by the LCD to simplify it and solve the resulting polynomial. Okay? So let's identify the LCD for this problem. Who's got it? What's the LCD for this problem? 18. It's got to be. It can't be 9 because remember the 2 doesn't go into 9 in the denominator on the right. 9 times 6, that's 54. That's such a big LCD. But 18 is divisible by 9. It's divisible by 6. It's divisible by 2. Therefore, the LCD is 18. Okay? Remember, it's the least common denominator. So let's multiply both sides of the equations by 18, please. Why did I put parentheses around everything? To remember to do what? Yes, good. Multiply both or distribute. So 18 over 9 results to give you 2. 18 over 6 gives you 3. And 18 over 2 gives you 9. Okay? What do we have left? 2x squared minus 3x minus 9 equals 0. We can factor this. What are the factors going to be for this? Definitely a 2x and an x. Good, Joe. Okay, but take a look. We have a 9, right? So our numbers can be 3 and 3 or 9 and 1. Let's try 3 and 3. If I put a 3 and 3 here, that's a good start. It's got to be plus and minus because it's a negative answer, right? So which one's plus, which one's minus becomes the question. Do you want the middle term to be negative or positive? Negative. So you want there to be a big middle term that's negative, right? So put the negative right here, please. Oops, it's going to show up in a second on your screen. I promise it will. There it is. So here, you're going to see the x minus 3. Why am I doing that? Because now this negative 3 multiplies by this 2x when I do the O in FOIL. Remember the outer term is the 2x times this negative 3 now, and the inner term will be the 2x times the 1x times the positive 3. Okay? When in doubt, how could you just solve this equation right here? Use the what formula? Thank you. Quadratic formula. Or complete the square, or write it in your quadratic program. Do something, right? Something. So what do we get as results? Who's got an answer for me? What do we get as the results for x's? Say again? Be careful, Joe. Thank you. Negative 3 over 2 and 3. Negative 3 over 2 and 3. Now, we should check this. Okay? For the sake of time, I'm not going to, but I'm going to tell you this. The check does work for both. So write yourself a little note. Check it tonight. Make sure you check your work. Okay? They both work. They both work. Joe. Where are we checking it, though? In the original. You're funny. Yes, in the notebook. In the original equation, not in the simplified version. Is that clear? The original is where you always check it. Because the simplified version may not be the correct simplified version. Maybe you made a mistake. And then you're checking into something that's wrong. So it may work and give you a false positive check. Okay? Joe.
On the final, we're allowed to have just the quadratic formula?
It will be clear as to what you have to do. If it says use the quadratic formula, you'll have to use it. If it says you can use your calculator, you can use it.
Will we be allowed to just have that formula?
On your calculator?
Yeah.
I'm going to probably show you another way. I guarantee you, you won't need the program by the end of the year. Let me put it that way. There's another way to do it that I haven't showed you yet, but we're going to get to it. So you won't need it, and it's pre-installed in your calculator, so you can't get rid of it. It's not a program. It's solving by graphing and looking for the x-intercepts on the graph. You know the x-intercepts on the graph? They give you the exact same answer. Okay? If it's imaginary, you won't see x-intercepts, and in that case, you have to use the quadratic formula. Okay?
Because you're going to let us keep them in there.
Probably not. No. So let's take a look at example 2. It's an inequality, but it's no different than the last one. It still has fractions in it. So we have to determine the LCD to start. We have to determine the LCD to start. 12. Why not 4? Remember, the number you pick, both denominators have to go into that. Okay, so 12 does not go into 4. 4 goes into 12. So the LCD is 12. So let's do it. Multiply by 12 on both sides of the equation. Another way of doing that, by the way, writing it is this. Look, you can just do this. Oh, no. There we go. Okay, you can just put a 12 out in front like that. It's got to be a multiple of whatever the current denominators are. Again, it's got to be a multiple of whatever the current denominators are. Alright, so that's what we're going to get as a result. Take a look, please. The 12 and the 4, this 12 and this 4 are reduced to give you 3. So put a 3 out in front. You're going to have a 12 here, multiplying by this 12. The 12 here and the 12 here cancel, leaving 5x. 12 times 3 gives you 36. Remember, please, again, I could say it a million times, this is going to every single term. It's distributing to all 3. Okay? And now, it's an easy equation to solve. Linear. 3 times 14. Quick math. Yeah, 42. Very good. Okay? Move the 42 over or the 36 over. It doesn't matter, but I would probably move the 3x over, making that a 2x. And then move the 36 over by adding it, making that a negative 6. And then you get this. Why did I do it that way? Because now it kept the coefficient of x to be positive. Remember, when the coefficient of x is negative, we then divide by a negative, which causes us to have to flip the inequality sign. To avoid having to even do that, solve it in such a way that the coefficient of x is positive. Is that clear? Okay. So this is the answer that we're going to get for this problem. If we were asked to graph your solution, you're asked to graph your solution. What does that look like? What goes in the middle? 0 should go somewhere, but negative 3 there is fine, good. Okay?
Why would it be on the left?
Oh, geez. It would not, at all, ever. I apologize, guys. Just making sure you're awake, that's all.
Yeah.
Always. So it's less than or greater than now. That's the key here.
Wait, closed circle.
Closed circle.
Less than.
And wait, anytime. It's going.
Still less than.
It's going.
Less than. Go to the left.
There we go.
Now, let's take a look here. Here's how we read this. Watch. If you want it, and if you want to rewrite it and you get confused, just write it like this. So switch all the signs or switch all the directions. Okay? And you can clearly see that its x is less than or equal to negative 3. Or just read it from right to left. X, reading it this way, this is a less than sign when going to the left. X is less than or equal to negative 3. Okay? Any questions on that one? We're doing well, guys. We're doing well. We got a few more to go. Number three. I know. Why am I doing this to you, right? But you have a quadratic now, and it's an inequality. So you're going to have to find your critical points. And you're going to have to test the different regions on the number line. Okay? Think back. LCD is?
6.
Good. Look at the product of your denominators, Ian. We have 2 and 3. So the easiest LCD to use is 6. Okay? Always the easiest. If there's one that's better, you can use it.
6s squared.
Not 3s
No.
squared. 8s.
Oh, I'm sorry. That's true.
You got to cancel with the denominator. Yeah, 3s squared. 6 over 3 is 2. 2 times 4 is 8.
And then 3.
Okay? So check your math, please, when you distribute. You can do 4 times 6 is 24 over 3, gives you 8 in the middle there. Move the 3 over, though, either way. Move it over now.
So now what do we do?
Remember, what do you do at this point? Who wants to step us through it? Factor, very good. It's clearly going to be 3s and s, and it's clearly going to be 3 and 1. Everybody see that? The only thing that can work is 3 and 1 there. Well, what is it?
3s plus 1 times s minus 3.
Very good, Jared. Very good. Take a look. The outer gives you 9, doesn't it? Look at the outer. It gives you negative 9, and the inner gives you positive 1. Negative 9 and positive 1 gives you the negative 8 in the middle. Okay, you got to be quick with that. Nice work. At this point in time, you can identify your critical points by solving these when equal to 0. So think of this as an equation now, and identify your critical points.
What is your thing with threes?
Why are you all sad?
Because,
I don't think they want to be
do you like Rhea?
I don't know, Joe. It's maybe one of those things I just do.
There's like consistently.
So these are not the answers, though, because this is an inequality, not an equation. So make your number line and put these on the number line. Let's do it. These are your critical points. That's why we wrote that. There's your number line now. Test your regions for positive or negative intervals. When testing, test 0 always first. Test 0 always. And you know where you're going to test it now? Look. You're going to test in this one always. I'm going to highlight it or circle it. Test here. It makes it a lot easier. And that was that one I showed you after talking to Mr. Linus. You remember I mentioned that. Test in this equation. Put a 0 in here. This is still positive, right? Put a 0 in here. This is positive. Put a 0 here. This is... So a multiplication of a positive or negative yields a... So when you test 0, it's a negative region. What do you presume the other two are going to be? Yeah, they both turn out to be positive. Be careful, it doesn't always work that way. We talked about that. What do we want this to be? Look back to the inequality. We see this symbol right here. It says greater than 0, which is positive. So we want it to be positive. So we shade in the positive regions with open circles. Why are they open circles?
Not equal.
Yeah, good. It's just greater than. See how easy this is getting, guys? This is like final exam review right here. This is a guaranteed question on the final. There's no doubt in my mind that this won't come up. Okay, and it'll probably come up as a rational problem like this. So that I test you on two things at once. Rational equations and quadratic inequalities. This whole topic is called rational equations, really, because rational means a fraction. Okay?
Oh, those are radical.
Rational. To do, and then we're done for the day. They are tough. We have 20 minutes. It will take us the 20 minutes. You need to write, and you need to write it all down. Again, feel free to bring in an iPad if you have one at home, and you could load the slides on your iPad, and this is all on there already. It would load the slides just like you see them on the board. You don't need to, though. I'm totally good with the notebook, especially in math. It's tough to use the iPad.
20 minutes, one problem.
No, two problems. So, what does the problem ask us to find, guys?
How many members?
So, we should start by saying let M equal the number of members went to the game. Okay, not the number of members that signed up for the game, because it said clearly 6 members dropped at the last minute. So we're going to say M is the number of members who actually went. Okay, and actually went. Now, can anybody give me a suggestion as to what to do here? This is tough. It's not an easy problem at all. Joe?
Plus 6 is the players on the team.
Say again?
And plus 6.
M plus 6 is the players that actually originally were there. That's fine. Or the original amount, let's say. Works for me. I like that. We don't need any more, but let's hear it. I'm curious, yeah.
I was going to say
Okay, and we're going to use that in an equation right now, that exact idea. Okay? But we don't need another let's statement. We're going to make it easier, but that's exactly what we're going to do. So we're going to look, and we're going to say, we're going to try and look at the cost for the members that are going. Okay? The cost for the members that are going. It says, when 6 members cannot attend. Okay? So when we're looking at the quantity M, each remaining person was charged $2 more to cover the total cost of $360. Okay, the total cost of $360. So the total cost is $360. And each player, there's M players, so we can say that's the amount that each player would be charged. Again, the game cost $360. M people went, so this is the cost per player. Is that clear? This is the cost per player. But originally, when there were more players involved, the cost per player was how much more or less? $2. So we have, and this is how we can say it, and we want to physically make a verbal statement if it helps. This is what I would say. The cost for the members going, and I'm going to highlight what I'm talking about as I say it. The cost for the members going is equal to the cost it would have been without the other members canceling. This is what it would have been if there were 6 more members, plus an additional $2. Again, the cost for each player going on the trip is the same as what it would have been with 6 more players, but it's $2 more than that. So an additional $2. So let's say it was like $8 per person. Now it's how much per person? $10. So it's like saying that this is the 10 on the left. The 360 over M plus 8 is the 8. And then the 2 is the additional $2 cost. Okay? So what can we do with this equation now? Solve it. Okay, but it's a little bit tough because our denominator has what in it? Yeah, a variable. So we have to think of each of those denominators as their own factors. We can't think of M and M plus 6 as the same factor just because M is in both. So what would the LCD be in this problem?
M plus 6.
Very good, Joe. We don't need an LCD from the number 2 because it's just a 1. So let's multiply everything by M plus 6. Things that cancel should show up as canceling. The M's cancel on the first part, leaving behind the M plus 6. The M plus 6's cancel on the second part, leaving behind the M. And nothing cancels in the third part, leaving behind 2, M plus 6. I know this is tough, but to me, the toughest part when I look at my notes is actually coming up with the original equation. From this point on, it's just solve. What kind of a problem are you going to have here? Give me a category of the type of problem this is. Good. It is most definitely quadratic in nature. What cancels on both sides that makes it nice?
360.
Yeah, 360.
M.
Thank you. It's on both sides of the equation, so you can drop it. Leaving us, and I'm going to move the 2160 over.
Why do they have big numbers?
You can do it. At this point, what are you going to use to do this?
You did like 12.
What didn't I do? Sorry.
I'm not gonna use quadratic form.
Yeah, I would use the quadratic program or formula at this point. Okay?
Could you factor out 2?
Yeah, like,
Absolutely. You can absolutely factor out a 2 and cancel the 2 as well. Okay?
can I just put this?
But I'm not going to do that. I'm just going to do the quadratic formula.
I would have factored it 2.
Okay? If you factored out a 2, it would look like this.
Or just divide the person by 2.
Then can you put it on the quadratic formula?
Then you could use the quadratic formula, or this can actually just be factored.
What is the quadratic formula for 100, 1000?
That's what it would look like. But that's messy, right? Okay, just to give you a heads up, so you wouldn't want to do that. The quadratic formula would just give you the two answers, which turn out to be negative 36 and positive 30. Can there be a negative amount of members, people?
Not really.
So we reject this solution simply because you can't have a negative amount of math members. So a verbal statement, there are 30 members. Going. Sorry, I should say going, because that's the key. Any questions on that one? I wasn't joking about taking about 10 minutes. It took us a solid 10 minutes to go through that. Now, what is the difficult part again? Really, what's the difficult part for these kinds of problems? Yeah, the equation is by far the toughest part. And the next example is going to be the same. Okay, the equation is definitely the tougher part. I'm going to go right into the next example here. If you got stuck there, please go to your quadratic program for now. You can check it later. Please write. This is a standard, what's called mixing problem. You probably saw this in chemistry for a little while. There's a possibility, maybe not. It's a bit complicated of an equation.
That's next year.
Sorry, I apologize. Next year in chemistry, you'll see it. You can do it, Ian. A chemist wishes to obtain a 500 milliliter solution of 26% solution of hydrochloric acid by mixing 18% and 30% solutions. So this means that the person has a really strong acid of 30%, and a weaker acid of 18%. But he needs to use 26%, he or she needs to use 26% solution in their problem. So this person needs to make 500 milliliters of that. So at the end of the day, he's going to mix some of 30%, some of 18%, and get 500 milliliters, and it's going to be exactly 26% acidic. This is very tough. Okay? It's very confusing. Now, if the numbers had been 27% and 25%, this would be very easy. It would be what, Ryan? Half and half. Because aren't these numbers right next to 26? So again, if these had been the solutions available, you do half of this, it would give you 26%, because they're evenly spaced. But 30 and 18 are not, which makes this much more difficult. So let's take a look at what we're going to do then.
Trying to get equal parts of both solutions.
Not equal parts, you're going to get different parts of each solution that will give you an overall mixture of 26% with 500 milliliters of that. Okay? So, let. It's our let statement. Remember, how much of each should be used? So let's say, let X equal, and we'll pick one of them. Let's pick the 18% solution. The number of milliliters of 18%. That'll be X. Then what will equal the number of milliliters of 30% solution? Not X plus 12. How many milliliters total do we have, everybody? 500. So, Chris? Very good. Again, we are mixing, say, 100 milliliters of one with 400 milliliters of the other. Therefore, they have to sum to give you 500. So if you take one of them away from the total, you'll get the other. And the total happens to be 500. Now, what else can we do for this problem? Let's take a look. The easy way to think about this is to make a table of information. Okay? And once you see this once or twice, it gets easier. So for the first time, try to just bear with me as what I'm doing. Okay? So, here's what we've got. Let's put a table, and let's make the table as follows. We're going to make it, let's say, 1, 2, 3, and then 1, 2, 3. Okay? A 4x4 table. And what we're going to do is the following. We're going to think to ourselves, and we're going to label this as the 18% solution, as the 30% solution, and as the final mixture, which to note is 26%. I'm going to call those rows. Now, in this column, we're going to put the milliliters of the solution used. In this column, we're going to put the percent acid in the solution. In here, we're going to put the amount of milliliters of acid in the end. And think about this for a second. If you've got 100 milliliters of some solution, 100 milliliters, and it's 50% acid, how many milliliters are actually acid? You have 100 milliliters, and it's 50% acid, so 50 milliliters are actually acid or acidic. Next, you have 100 milliliters, and it's a 27% solution. How many milliliters are acidic? 27 milliliters. So whenever you multiply the milliliters of the solution by the percent of acid, you get the amount of milliliters that are acidic. Agreed? We want this to be 26% acidic of 500 milliliters. So let's take a look at the bottom. We have 500 milliliters that we want, and we want it to be 26% acidic. So we just multiply those two. That's what our goal is. We want to have 500 milliliters of some solution, and we want it to be 26% acidic. So that's how much acid we want. But let's take a look at how much acid we have available. We have X amount of the 18%, that's given from up here. We have 500 minus X amount of the 30%. The percent acidic is 18, the percent acidic is 30. And let's multiply. What happens here? What happens in this problem is that we know that we need a certain amount of milliliters that are acid. It's given at the bottom right here. This 0.26 times 500, that's a quantity. But take a look up here. The sum of these two, since we're mixing them together, should equal this. The amount of acid that we mix together in these two parts should equal the amount of acid total. So let's add this with this and set it equal to this. So our goal is to take a look at this column now. And we add the first two up to get the third. The amount of acid available from this one and this one must equal the total amount that we're looking at in the problem. Let's go ahead and do that. Now, that's going to give us 130, by the way, on the right-hand side. And the product of these two is 130. What can we do now? What kind of an equation is it? It's not quadratic, actually. It's just linear this time, right? So, you might be asking yourselves, why is this even in this section with fractions? The reason is the coefficients are decimals, which are really fractions. So we're considering this to be part of this topic, and we haven't hit a mixing problem yet this year. And it's an important topic I wanted you guys to see. So let's go ahead and take a look. We have 0.18x plus. Now 0.3 times 500 is going to give us 150 minus 0.3x. Okay, move the 150 over. 0.18 minus 0.3x is going to give us negative 0.12x. No? I thought so.
Isn't it 1.5 or?
1.8 and 1.2 gives you 1.3, right? 0.18
Oh yeah.
minus this.
Oh, it's 0.03.
It's alright. And then divide by negative 0.12.
Why is it negative 12x, Mr. Owl? It's positive 18 minus negative 0.3. Positive 18 minus 0.3.
Because this is minus 0.30, right?
Oh.
Why is the other side negative 100?
What is the side? 40s.
That's why. Sorry. Thank you, Kate. Okay, this part is correct, guys. This is really 0.30. This is like negative 30 and positive 18, which gives you negative 12. Okay, the decimal part is right. The negative 20 was the correction. Thank you, Kate. Divide by the negative 0.12. Check your answer, please. Make sure it's right. Now, what we have to think about is this is our answer. What did the question ask us for? How much of each? This is the amount of how much percent solution. Which percent solution represented X? Look back up at your let statements, people. Yeah. So we say there are 166 point, let's say 7 milliliters of 18%. And let's do 500 minus that. Should be 333 and a third. And 333.3 milliliters of 30%. It's 18.
It wasn't dry as well.
Say it one more time.
Why just buy 26%?
Why don't they just buy some point? It's not available. A lot of answers don't come in certain, like, you can't get everyone that exists. Think about it. If they need everyone that existed, they would never sell them all. So they sell certain numbers and you make it from that one. There's computer programs that you can just run to do this calculation for you now. It's easy.
Why doesn't he use that?
It's like a matrix, you know, you practice by hand and you learn a matrix. Who's he?
The guy you made up with like your chemist.
Because the chemist wanted to do it by hand. I don't know, we're trying to show how this problem is there.
Yeah,
Guys, you have to understand, computer programs don't exist unless people know how to write them. People don't know how to write them unless they understand them. So if you ever want to think about this as far as like writing goes and understanding what's happening, you need to understand what's going on. Now, please keep in mind that we talked about in the beginning, if availability were 25 and 27%, you would just use half of each. Your homework tonight is as follows. Okay, multiples of 3 from 3 to 24, and then 4 different word problems. You're going to have a mixing one, you're going to have a group member one, you're going to have a very easy one in the beginning, and then you're going to have one with distance rate. Okay, think back to the old distance rates we did and related here.